Hello, how you doing, family? So we have some of the integration here, okay? So I'm gonna show you the easy way how to do it, okay? Let's get started. So let me start with this one, okay? I'll start with this one and I'll count for 8 over 2. So if somebody give you integrate that one, so what I'm gonna do, I'm gonna say integral, I'm gonna introduce, okay, we have sec x. Look, I'm gonna introduce here sec x plus tan x. And then I'll do the same thing under the bottom. So this is like, it doesn't have an effect because okay, well, you can cancel each other. So multiply that out. When you multiply, that's going to be sec square plus sec tan. Okay, and the denominator we have a sec x plus tan x. We still have dx. So I'm going to let u or any letter equal to the denominator sec x plus tan x. When you differentiate this, it's going to give you sec square plus when you differentiate when you differentiate sec is going to give you sec tan, sec x, tan x. When you differentiate tan, you're going to get sec square. Okay, this will give you sec square x dx. So all of this is this. Can't you see? Sec square is sec square. Sec tan x. So I'm going to replace that with du because sec x dx dx equal to du. So I'm going to say integral du 1 over all of this stuff equal to u over u, and we know 1 over u equal to ln. So ln of u, I'm going to put my absolute, but what is u? I know my u equal to sec x tan x. So this is equal to ln sec x plus tan x plus constant. So when you integrate sec x, you get ln sec x tan x. Let's go to the question number. Let's do that one. Okay, let's go. So we have here integral sec cube. So okay, sec is cube, we'll say sec x and sec square. See, and then after that, I'm gonna do by parts. This is integration by parts. So let u equal u equal to sec x, and then du dv equal to sec square x dx. This is by parts because by parts say integral u dv equal to, for the people who don't know, v du. So I'm gonna let u equal to this and dv equal to that. So now differentiate the first ones. When you differentiate this, it's going to give you du, and when you differentiate sec, you get sec x tan x. Now integrate dv. When you integrate dv, it's going to give you v. When you integrate sec square, so first of all, let's simplify. When you integrate sec square, you get tan x. Okay, so what I'm going to do now, I'm going to substitute in the equation there. So I'll say all this integral of sec cube equal to v. What is u? U and v. Sec x tan x, sec tan x minus integral of v. What is of v? V equal to tan x. So we're going to say this is going to be tan x, and then multiplied by du. What is a du? These are du. So du sec x tan x. So this tan x is going to be multiplied with this, going to be 2 of them, and then I'll be left with sec x. So here I can simplify. Tan x is equal to sec square minus 1. How did I know that? Let me just show you for some people to know. Look, sometimes you tend to forget the, everybody happens. You can forget the identity. So how do you remember? You go to the key identity. The key identity is this one, sine cos square equal to 1. Sine square plus cos square. So if I want to get tan square, how am I going to get tan? Tan I know is sine over cos. So then divide is sine over cos, right? So divide everything by cos. So I'm going to divide here by cos because tan, this is going to give me tan. Everything divided by cos, but everything must divide by the same thing. So now this is going to give us tan plus 1 equal to 1 over cos equal to sec square. So can't you see, if you want to replace tan square equal to sec square minus 1. So this is going to be sec square minus 1. So now let me leave this for so long and then let me deal with this one here. So I'm going to say, let me take this one here, okay? So I'll say this, let me say integral, okay, the sec square minus 1, and then you have to multiply by sec x dx. But I can multiply this. When you multiply this, it's going to be sec cube and sec x. So this is going to become sec cube I can do next line of right. Okay, sec cube, and this can become sec x. So let's move this, say sec x. But I show all the steps, right? Sec x and then dx. So I can separate also this integral. So I can say integral sec x. Okay, but when we have it minus like this, so I can say integral of the face one, which is going to be, this going to be minus sec x cube x, and this will become positive integral of sec x dx. And you have integral of sec cube dx equal to sec x tan x minus. So don't you see this and this are the same thing? So I can simply take this one, sec cube, to the left because they are like 10. Okay, this, because it's the same, so I'll take 2 to the right. So since this is negative, when it comes to the right, it's going to become positive. So it's going to be 2 of these, and that will become 2 of integral of sec x equal to sec x tan x, which is this, and then plus. But when you integrate, and then plus, okay, plus what? Integral sec x. But when you integrate integral sec x, we did it previous, equal to long sec tan x. This is going to give us integral of sec, we did it in the previous question, tan x. Okay, so what we're going to do then with plus c. So we can simply divide by 2 throughout because we want to get integral sec cube x. Sec cube x. So divide by 2, divide by 2, divide by 2. So this is going to become a half, and this is going to become what? A half, and this is going to go 2 divided by 2 equal to 1. So I don't need this anymore. So finally, this is our final answer here. Integral sec x equal to half sec tan, a half log of sec tan plus c, constant. Why we add constant? Because there's no limit. Let's go to question number 1. Question number 1 is easy. Okay. So question number 1, don't do the same approach we just did now. Say, oh, this is cot. So since it's cot cube, let me do by part. It's going to be tough for you. Okay. So not all the time we just jump by parts, whatever. So you have to do a lot of questions for you to identify when you look at the question. You know, this must be by part. This should be substitution. So do so many questions. Like me, if I look at the question, I know exactly like this is by parts, this is by substitution, because I've done millions, thousands of questions. Okay, now let's go. So this one cot cube. Cot cube, I'm gonna do the same approach of separate. I'll say this, let me say integral, or the pen is finished, okay? Integral. I'll say integral, this will be cot x, and this will be cot square x dx. So now this one I'm not gonna do by parts. What I'm gonna do, I'm gonna replace this right here. So for cot, don't just go with part routes because it's gonna give you a problem. Don't take that path. So I'm gonna replace this. So I'm gonna know this trig. Like I said, if you forgot, go to your key, identity to the trigonometry. When you say sine x plus cos equal to 1, I wanna get cot. What is cot? Cot is cos over sine. Cot is cos over sine. So it means I have to divide by sine throughout. Divide by sine throughout. Divide by sine throughout. Divide by sine throughout. Look, sine divided by sine equal to 1 plus cos divided by sine equal to cot. But there's a square here. 1 divided by sine square equal to cos x square. Can you see? So you want to replace cot square. What is cot square? Cot square equal to cos x square minus 1. Oh, so this is going to be cos x square minus 1. So I'm going to have an integral of cot x. And here it's going to be cos x square x minus 1. And then this is going to be dx. So I can just open that up. So it's going to be integral cot x cos x dx, because it's going to be this with the dx and then cot x. So it's going to be minus, because it's minus integral of cot x times 1 is cot x dx. Cot x dx. So now I'm going to do, this is simple here. This is equal to ln of sine. When you integrate cot x equal to ln of sine. So now let me deal with this. So I can just simply say this minus ln absolute sine x plus constant. But now let me deal with this one now. So this I have to let. Which I'm going to let? I'm going to let what? Cosec. So let cosec u equal to cosec. And then when you and then I'll differentiate. When you differentiate the u, you get the u, and when you differentiate cosec, You get cosec negative, when you differentiate cosec, you get negative cosec cot, negative cosec cot dx. Okay? So long, let me just keep like this. So this is from that. So negative cosec cot. So look, I have to use a brain now. So I have to come and replace something here. So first and foremost, we don't have negative. So let me take negative to the left. So say this negative, come here. Why? Because I look at this one. How can I substitute this expression here? Cosec x, I can get 1 cosec, that is square cosec x. Means if I have to replace 1 cosec x, means I have to remove that, and cot x and cot x. So if I have to replace cosec x, 1 cosec x, and cot x means only 1 cosec is going to be left. So I'm going to say integral. If I remove cot, 1 cosec, and dx, we're going to replace with du, but it's going to be du minus, so minus at the back. So here I'm going to be left with a cosec. Let me write like this, so I can do step by step for some people. So only 1 cosec is going to be left here, means 1 cosec is going to be left. And then cosec dx is going to be du. But what is cosec? Cosec equal to u. So I can simply say here u. So this one is saying negative integral u du. Okay, now, so this is power of integral. Power integral, and this is like a power 1. 1 plus 1 equal to 2. So it's, let me say u square over 2. So all this stuff here equal to u square, but there's negative. You see? And what is u? U we know. U equal to cosec x. So I can just simply, okay, let's just come here. Say this is equal, okay, negative u, so it's going to be negative u. What is the u? Our u equal to cosec. So I can say cosec here. Cosec x, but a square over 2, and then we still have our, when you integrate cot, you get negative ln sine x plus e, okay, minus ln sine x plus e. But what is cosec? Cosec is 1 over sine. Cosec is 1 over sine, so we can just say this equal to 1 over sine, but a square, right? And then we have our 2, watch your 2 here, we have a minus, and here we have a ln sine of x plus constant. And then we say, let's finalize. So meaning, so finally, when you integrate cot cube, you get this answer. So you can either write like that, or you can start with this, or you can take negative. We've done that's what you can play around. Or let me start with a negative ln. It's a negative ln sine, however you want. It's your option now. Minus 1 over 2 sine 2 x plus c, this minus here. Or if I don't want to do that, I can just take negative out. Now you play around however you want. You're done with your equation. So I can just say, I can take negative out if I want. Ln of absolute sine of x plus 1 over 2 sine x plus c. So this is the answer. It can be this, it can be this, it could be that. Either this or this or that. All of that. You'll just go all the way to the end. So when you integrate cot q, this is the answer here. Negative 1 over sine or this or that one. Look, I believe in how to do things. So if you face time, please come subscribe. Share this with a lot of people. And yeah, just go and visit my website. Thanks a lot of your time. Peace. And I'm out. Amen. I'll see you soon, right? I'll see you very, very soon, okay? Like I said, first time, come right here, subscribe to my channel, share this with a lot of people. I'll see you very soon. Peace.